Hello viewers, Eric the Car Guy here, back again with another repair video for you. And as some of you might be pleased to see, I have a variant of a Ford parked behind me. It is a 2004 Mercury Marquis, which is virtually the standard full-size Ford that's been used, just about since they started making Fords, it seems. So yeah, this body style has been around for quite some time, so I'm sure this information will apply to many different things, like full-size Ford about this size. The reason why it's in today is because the blower motor is not working. So I'm just going to go through the quick and dirty process of trying to figure out why that blower motor is not working and repairing said blower motor problem. So it's not too heavy a deal, but you know, it's something that's got to be done. So first, let's go over to the vehicle and verify the complaint. Okay, yes, I'll admit it. An old lady drives this car. A nice old lady. But she is having a problem with her blower motor. So let's get a look at that. Okay, actually, it is working. I have the key turned on, by the way. And the mileage is roughly 79,000 miles. So this is a very low mileage car. But from what I'm seeing here, it's actually working. I don't know if you can hear that, but it's not working so well. I mean, I'm trying the different settings, and it seems like it's getting the same speed no matter what I'm doing. So I guess it is working, it's just not working as efficiently as it could work. And that could be due to several things, but this is kind of an important point when you're verifying this. If, say for instance, you didn't have any low speed or any of the medium speeds, but you did have a high speed, now that would indicate that most likely that the transistor or resistor assembly, depending upon how it's set up, is the problem. Because for these lower speeds, the blower motor actually gets a reduced voltage because it goes through that blower resistor or blower transistor, depending on how it's set up. And if you notice that it's not working on any of these lower speeds, it usually means that's, oh, here it's kicking up a little faster now. It usually means that resistor is having a problem. I'll go one step further. If you can turn it on to high and it works good, but all these other speeds it doesn't work, that's the blower resistor, because when you put it on high, it gets full voltage. With any of these lower speeds, it would be going through the blower resistor or transistor. So that would be a good indication of what the problem is if you only had high speed. But since it just doesn't seem to be putting out what it should put out, and they told me that it wasn't blowing any air whatsoever, and it is now, that leads me to suspect like maybe there's a problem with the blower motor itself. So let's go use a highly scientific test to see if we can determine what's going on here. All right, on this vehicle, we are fortunate enough to have the blower assembly located here out under the hood, which is kind of nice because it makes it so we don't have to crawl up under the dash. But you can hear that the blower motor is working. And if it wasn't working, what I do sometimes is, this is the highly scientific test that I spoke of, is just smack on the outside of this assembly, and if it starts working then 9 times out of 10 it's usually the blower motor itself that's bad. As far as that resistor assembly, that's usually located in the or just the HVAC housing somewhere. Okay, so say I came out here, the blower motor wasn't working at all. This would be my first step, is I'd want to make sure that the blower motor could work. And the way I do that is I disconnect the connector going to it, and I would check to see if there was power and ground. Now I have my power probe here, but you can also use just a test light just to find out if you have power going to the blower. So if when you turn the switch on, I'm going to turn the beeper off. If when you turn the switch on you see that it's got power, you see my red light lighting up there, that usually means that the wiring and everything else in the switch is okay. If you didn't see power, you also have to look for a ground. Here's the ground. So you should just, it's a very simple circuit. It gets power, it gets ground, and that's the way it is. So if you turn the switch on and you see you're getting power and you see you've got a ground, then that usually means that it's going to be the blower motor if it's not working. If you don't see a power and ground here, then you have to look elsewhere in the circuit. It could be the switch, it could be a problem with wiring, or like the control unit for the HVAC. It's really difficult to say, but For the purposes of this video, we're just going to diagnose the blower motor. So first thing I do is look for power and ground. We have both. So that means that the motor wouldn't be working. And because mine is working slowly and not really good at all, I'm actually just going to go ahead and replace this blower motor. And the other thing is the complaint was it was not working at all sometimes. And that usually indicates that the blower motor itself is going out. All right, now I'm just left my electrical connector disconnected. It looks like there's a couple of things at play here. There is a this tube here that basically cools the blower motor that I'm just going to pull off of there for the moment. And there's also some electrical harness stuff that's around the outside that I'm going to have to deal with. So those came loose pretty easily. They were just on there. But it looks like we have 4 8mm fasteners around the outside here. I always like to start with the hardest one first. I have special universal sockets. Oh, that works. That works nicely. Once those 4 fasteners are removed, I'm hoping it's just going to be a matter of, well, it looks like that bracket comes up out of the way. And there we go. Getting those wires out of the way is going to be a pain. So my new blower motor doesn't come with what's called the Squirrel Cage here, so we're going to have to switch that over. Let's head over to the bench. All right, we're going to call my cart our bench for today. Here's my new blower motor assembly, and I just want to briefly compare it to my old one just to make sure that they're the same or close to it. This is an aftermarket part, so I want to make sure that it's going to fit. So it looks like everything's good here. But what I'm going to need to do is I'm going to need to transfer this, it's called a Squirrel Cage, this part of the blower motor over to the new part. It looks like there's also a gasket in here that if I could save that, great. And then there's this vent tube, which basically this cools the blower motor, so it uses its own airflow to help cool the motor assembly. One of the first steps I'm going to need to do that is you'll notice there's like a little clip, little metal clip here on the end of this shaft. We're going to need to remove that. Now, you may employ several different methods to do this, but luckily my new part came with a new one of these clips, so even if I destroy my old one, I should be okay. Just very carefully, because remember that this is plastic. Yeah, that came off actually pretty good. This is plastic. You break this, it gets even more expensive. So now that I've got that clip off, I'm just going to take my hammer. Since this is the old blower motor, I don't really care so much. And I'm just going to try to tap it so that I can run it right through and possibly get my squirrel cage off. I need 3 hands. Actually, I didn't need to hit it anymore. Once I got it past that certain point, it came right off. I've had some of these on certain makes that just were kind of a nightmare. So I don't see any damage to this, which is excellent. But I do see that this old part has a gasket that I'm going to try very hard to preserve and to swap over to my new part. I'm also going to take out this rubber tube, which, as you can see, I could just peel right out of there. I suppose it would help if I was trying to put it on there correctly. Okay, old assembly, set that aside. You'll see that the shaft has a slot on it. You need to make sure that you line that up with the slot in the squirrel cage here. Went on very easy. And I'm just going to use my new clip, even though my old clip is not damaged. EricTheCarGuy defeated by a plastic bag. And this can go on one of 2 ways. And I'm going to put it on, you see there's like a cone shape. I'm going to put it on like this, so the cone faces, the inside of the cone faces the inside of the squirrel cage. Just gonna get it started. Actually, what I was gonna do is I was gonna get a socket about this size and push it on, but it seems to very easily slide on like this. Now spin it, make sure it's not making contact with anything. And next, we'll install that vent tube there. Remember, it goes towards the blower motor assembly, so just gonna there we go. So now that's in position, and our gasket keeps falling off, but I kind of expected that. All right, now I'm going to go just install it on the vehicle. Okay, I remember this being kind of tricky to get out of here, and mostly it was because of these wiring harnesses and things. I made life harder for myself by putting this gasket back on. But it's going to help with the air seal. Come to think of it, it might have been easier to install this gasket onto the HVAC assembly before I put the blower motor on, or maybe even to have gone so far to like use some gasket adhesive or something like that. Now let's reinstall our 4 fasteners. Let's not forget we had this bracket here that came down. There's some locating pins on the plastic housing that will be helpful in getting this on there. And like I say in many of my videos, I like to get all my fasteners started before I run them all down, just to keep things from getting bound up. Don't forget to reconnect your vent tube. Now we've got all 4 of those back where they need to be. Put the harness connections and everything back together. Blower motor connector is slightly different than the old one. There was something that was mentioned by my parts person when I went to order this blower motor, and that was the possibility of needing a harness connection for this. And it was quite expensive, and honestly I don't know what's involved with that, but you may run into that situation should you go to replace one of these blower motors. And unfortunately that's not the case with this vehicle, so I'm unable to show you what you'd have to deal with should you have a harness connection that you'd have to deal with. But now that we've got the new blower motor installed, why don't we test it out and see how it works. I'm gonna be honest, it doesn't seem like I'm getting as much out of that blower motor as I was hoping. I was hoping to see more from it. It's odd how actually this speed here actually has more than that speed there, than the high speed. High speed should have like full voltage going to it, but for whatever reason it's not. Now that could be something with the climate control unit, or it could be something in the wiring. I'm really not sure. Okay, let's recap. Where do we stand on our 2004 Grand Marquis with a blower motor issue? So what I found initially is that the blower motor was receiving power when you turn the switch on and you turn it through all the settings, yet the blower motor wasn't actually working. After fiddling it with it a little bit, it seemed to start working. I replaced it anyway because I suspected a bad blower motor. But now the blower motor works, but the problem is the output just isn't what's expected. It seems to be just sort of doing a fraction of what it should do if you turn it on the high position. So I found a couple of things I'm going to bring you in on. I also grabbed the wiring diagram so that we could see what we're dealing with. And I'll give you my theory as to what's happening and how I'm going to proceed from here. All right, here's something that's important to note. This body ground connection right here, I've restored. I actually put my own screw in there. Just while looking for the blower resistor, which actually lives down here underneath these heater hoses, which we will actually get to today probably, I noticed that ground connection was not tight at all. In fact, from the factory, it was just sort of hanging there. Now, I'm not sure if that's the ground for the blower motor itself, but body ground connections are very important in that they usually ground several different components. If a component can't ground through its ground, like say to here, it'll usually backfeed through something else if that's possible, and as a result, it won't work as well. So that's one of the reasons why I went after that body ground. All right, here I've laid out the wiring diagram for the circuit, and it's a little confusing to read these sometimes because you have these switches in here, but I'll do my best to try and bring you up to speed as far as what I'm seeing here. Wiring diagrams normally go power distribution at the top and then work their way down to grounds at the bottom. So I'm going to start with the power, which comes in at the battery junction box here, and it looks like fuse 16, which is a 15 amp fuse. So that comes through this power junction connection. It powers up everything inside this switch. Goes down through the switch, and we can see over here the different states. See how all these are numbered? And as you can see, position 1 over here is max. Position 1 here is max. So anyway, we've got it on high. The power transfers through this switch down through this connection here at B. I don't know if you can see that well. Well, then we come down to our other page, and we can see that B comes in here and goes through a relay that's in the fuse box underneath the hood that grounds the coil for the relay here, and it grounds here at this G102. So that's the relay side of the circuit. That's the control side of the circuit. I'll put a link in the description to how relays work and how to diagnose them to give you a little more information on that. So this is where the blower motor itself gets its power. Here's our blower motor. It's going to get its power from, looks like fuse 103 maybe, and it's a 40 amp fuse underneath the hood. So I'm pretty sure that this fuse is good because the blower motor actually works, but we can go and put our eyes on it just to make sure. If this fuse was bad, I doubt the blower motor would work at all, since this is the main power feed to it. But anyway, as you can see, it comes down, the relay is energized. When it's energized, the relay closes and provides power to the motor. Then that power still goes through the other side into A here, and back up here at the top of this diagram we meet A again. And it comes down through this part of the switch that's in the climate control. And we can see over here that position 11 is the high position. Power comes down through here inside this switch, and then it'll change to ground. I sort of messed up when I did this. And then it'll ground here at this G201. But as I stated, in high position, it bypasses this, which is the resistor assembly. So it's not even going through this resistor assembly here. So looking at this wiring diagram, I'm actually beginning to suspect that our problem is here inside the switch assembly. I had thought that perhaps like maybe there was some sort of modulation that was going on, or something like that controlled blower speeds through this resistor assembly, but that's not the case. It looks like it's a traditional blower circuit to where when it's on the high setting, it bypasses the resistor because the resistor gives you those slower speeds. High speed, you're getting full voltage. You're getting your full 12 volts. So what I'm going to do now, just to verify this, is I'm going to go over to the blower motor connector itself. I'm going to put the switch on high, and I'm going to check to see what kind of voltage I'm getting to the motor itself. If I'm getting a full 12 volts, then maybe our problem is more like on the ground side or something like that. But that's what I'm going to verify. I'm going to verify, one, I'm getting 12 volts going into the motor here, and also verify my grounds. So let's see what we got at that blower connector when we turn it on high. Okay, before I do that, it's good practice whenever you're doing electrical diagnostic work to check the battery voltage. Everything begins and ends here at the battery as far as the automotive electrical system is concerned. If you don't have good battery voltage, then nothing else is right. And you'll know if you're getting full battery voltage if you know what that actually is. So I'm going to start by, I have my settings on here set to the 20 volt scale, DC. I'm just going to quickly check what my battery voltage is. And my battery voltage honestly could be better. It's 12.356-ish. A good static charge for a battery should be 12.6 on a good battery. So this battery may be showing its age at this 12.35, but I'm not going to concern myself too much with that right now. I just know that I have a full 12.3 volts here at the battery. So now I'm going to check my connector at the blower motor and see what I have there. Okay, over here is our blower connector. Now I'm going to turn the blower on high, turn the ignition on, turn the blower on high, and I'm going to check my feed voltage going to the blower itself. Okay, now we're inside the car. We need to turn the ignition to the on position. In order for this to activate, I'm going to turn the blower fan on high and it doesn't really matter what this stuff is on. Blower fan is not working now, remember, because we actually have it unplugged. So we have to go, let's go check our voltage and see what we've got there. All right, here we are at the blower connector. And this is the feed coming to the blower motor. This goes directly to the blower motor. So I'm going to take my voltage reading from right here in these two metal contacts here. All right, let's see what we got. All right, it's not full battery voltage, but it's darn close. It's only a few tenths of a volt shy of where we would be. So we had a 12.3, we're looking at 11.98, so we got pretty darn close. All right, just to satisfy my own curiosity, I'm going to do a voltage drop check after the blower motor itself. So I'm going to see what kind of voltage is going through the blower motor. I'm going to take one lead and I'm going to connect it to battery ground here. And then I'll take the other lead and I'm going to plug the blower motor back in, because when we do voltage drop checks, we want to do them on live circuits. Plug this back in and I'm going to back probe the connector on the power side of the motor. So I'm dropping about 11.85 volts across the blower motor. Also, just for the heck of it, I'm going to do a voltage drop across that ground. So I'm going to touch one lead to battery negative and another one to the actual ground that I suspected was bad. And I don't know if you can see that there, but I'm only seeing about 1/10 of a volt that I'm losing there. Which makes a bit of sense, because you're going to lose a little bit through wires and things, but that's about what I'd expect to see. I don't want to avoid skipping the most basic of steps, so I'm just going to look in here at these fuses. I'm just going to do a visual inspection on these, because our blower motor has a 40 amp fuse. So I'm going to look and see if any of these 40 amps, and those, it looks like those three are the only ones there, and I'm going to look at them all just in case. But then our other fuse, I believe, was a 15 amp, also located in this fuse box. I don't see anything blown there, but with these micro fuses, it's sometimes hard to tell. So what I'll do is I will take my meter, I will take a ground lead, and touch that to ground. It'll stay in there. And this fuse is hot and run, so I'm going to turn the key to the on position. Key to the on position. And I'm just going to take my other lead and touch the ends of these fuses. And I'm not sure I have the best ground connection here. And that's what we're looking for. We're looking for battery voltage on either side. If we get to one and we find one that doesn't have any voltage, we know that that fuse is open. So all the 15s are good. I'm just checking the rest just to be sure. I just found that to be good practice when doing work like this, is if you have a problem with something and you're checking fuses, don't just check one fuse, check all the fuses. We have voltage at all these fuses, so I don't believe it's a fuse issue. All right, I've made the executive decision, if you will. Rather than try to poke around for grounds that I, may or may not go to what I need them to go to, why not go to what I know, which is the backside of this assembly. I do know the wire colors that are supposed to come out as far as the voltage come out of here. In other words, I could actually take out this unit and bypass it. And if I'm able to bypass it and get it to work, then I know that the ground is okay out there, that it's really just something inside this switch. So I'm gonna start with this, and I think you can remove this trim piece here. All right, I'm going to need another hand. Unplug the defroster. said unplug the defroster. Oh, maybe this will help. Yes, it will. So it's not all that difficult apparently to get this out. Looks like we just got 4 fasteners from here. Let's see how it works with a 7mm. This reminds me of working on my Galaxy. We've got some vacuum connections here. This is still old school vacuum operated. And considering I'm not going to need to worry about any of that, I think I can get to what I want, which is this switch. These wires of this switch right here. So as I said, it looks like the blower switch is removable, and I'm going to do just that. That just pulls right off. And then there's one fastener on the back here that is a 1/4 inch. I'm just going to remove that. Since my testing is really just concerned with the operation of the switch, I can leave the rest of the HVAC stuff attached. I'm of the opinion I'm not going to do any more work than I have to. Okay, we've separated out the switch. I can actually go so far as to put this back on. I can work the switch outside of here. Now I'm going to see what the outputs are. And for that, I'm actually going to go grab my power probe because it might be easier to do that. Alright, to do our testing, I'm going to need to put the key in and back in and turn it on. That's ground. Also ground. That's nothing. Nothing. How odd. Normally you'd see power somewhere, and I'm not. And guess what else I see that I just spotted? Melted connector. Alright, to give you a closer look, right there. Whenever I see melted connectors, there is a problem. You can see how that's just sort of pulled away. So I'm going to unplug this right now and actually bypass the switch and see what I get. Alright, turn my key off. If I can disconnect this. Okay, you can actually see a little better the melted stuff, and in fact it looks like I can pop this open, and if we can, I'll do that here in a minute. We'll take a look inside and see if we can find out our melted parts. But my next step is going to be to find out what goes to what here. Let's see. Turn the key on. Got my power probe out so you can actually see ground, nothing. Nothing. I'm a little confused by that because it seems to me that the switch should have some power coming to it. The fact that it doesn't is significant. That either means like that relay is having an issue. In fact, it probably does mean exactly that relay is having an issue, because I should see power here. And the fact that I've got the switch unplugged and I'm hearing the blower motor running, turn this off. Everything's ground now. Let's just try AC. Yeah, all I have is grounds here. I'm thinking I should at the very least see some power. Okay, so I took a little break, had a little lunch. You know, sometimes it's good to walk away from a problem like this. And I kept thinking about this switch and the fact that it was melted. So I took the liberty of taking it apart, which quite simply I just had to pry it up like this. You have to be careful when you do this because many times there's spring-loaded components and stuff could go flying. So I was very careful when I disassembled it. I opened it up, and this is what I found. So what I found is those contacts, particularly right here, were not making good contact because it was covered with plastic. The plastic had melted in this area. So I went and I took my razor blade and I just scraped the plastic off and got it out of the way. Then I put it all back together. This is the inside of it, by the way. So you've got your main power feed coming in there, and as you rotate the switch, it transfers that to different places on this, which in turn goes to this side of the connector and sends everything to different components in different places. It only goes together one way because there's that little slot there that slides into that switch. Clicked it all back together. I plugged everything back in, including, well, this is my new resistor, not the old resistor. Plugged all this back in, and now let's go plug this in under the dash and see what happens. All right, everything's plugged back in. Put that back on. We'll plug our switch back in. And let's give it a shot. Guess what? We got full fan now. Everything works. So the problem the entire time was the contacts here inside the switch. As far as that short to ground that I was trying to chase, looking at the wiring diagram a little closer, let me bring you over. Okay, this is our path to ground here. And it goes up through this switch, which goes through these different selections through the blower resistor, which also has a ground. It's that big black wire coming out of it. So whenever you plug this in, it creates this connection to ground. And therefore, I'm thinking that this is where I was thinking that there was a short to ground, because in essence that's how the circuit works. This orange black becomes the ground once it crosses this point. So once it crosses the motor here, I should have actually marked this like this. Once it crosses the motor, that's our ground. It comes into here as a ground. So this whole side of the circuit should have been thought up that way. So it was my own idiot mistake, and I will freely admit it, that led me to tear apart that harness and everything. I should have just stopped at the switch and replaced the switch and been done with it. But I did find a problem with that switch, which I believe I've corrected, and I think everything's going to be fine from here on out. But I could have saved myself a lot of time had I, not continued to create a problem where there wasn't necessarily one. Well, I've got my work cut out for me putting this thing back together, but lessons learned, let's say. We all have days, and today was one of mine, and I got to bring you along with me, and we end up with a big mess to clean up at the end of it. Yay! But I say the important thing is we're walking away with a fix. The reason why this happened was because that part of the switch wasn't making contact. Now, if I have a theory, some of you might be thinking, well, if you put this switch back in, and who's to say it's not going to have a problem again? My theory on that is that when I first started my diagnosis, I checked to see if I had power and ground at the motor. I did when the switch was on. However, the motor was not working. So that motor, at least at that point in time, appeared to be burned up. Maybe through moving it and taking it out or whatever, it started working again. That's entirely possible, but I say that motor was bad. And possibly because of that, it backfed through this switch, because as you can see, the switch is the ground for that circuit. So if that's the case and a whole bunch of resistance was going through here because the motor was having an issue, well, it could have very well done the damage to the switch, melted that plastic and opened up that contact, not allowing us to have full blower speed. So that's my theory, and I'm sticking to it. But once again, the takeaway is if you find a problem, address the problem. Don't keep looking for a problem, and also know the circuit and know how the circuit works. And I wasn't completely up to speed on that, and as a result, I ended up on a wild goose chase here, so see if you can learn from my mistakes. I am Eric the Car Guy. You can always find me at EricTheCarGuy.com, where if you have automotive questions, I would ask that you head over and type a couple of keywords into the search function at the top of the page. It combs through thousands of things that I've already answered amongst other people who have also answered questions. You may find an answer to your query right away. If that's not the case, feel free to sign up for our forum. It's absolutely free. All you need is an email address. Just be sure to respond to the confirmation email if you don't see that. Check your spam or bulk folder, see if it's there, and click that activation link. Aside from that, if you want to connect with me socially, you can find me at Google+, Facebook, and Twitter. And I close each and every video with, be safe, have fun, and of course, stay dirty. Okay, I know some of you viewers out there really want closure with this, so here we are. There's some of my handiwork. I rewrapped all of these wires and rerouted them back there. I haven't put the fender liner back in yet. Relay box is all back together. Put the dash and everything all back together also. This is where we're at. And there we go. Got full blower motor now. So I hope that helps those of you that were wondering what this was going to be like when it got all back together. So it's all back together. It's all good to go. We're going to ship it out of here. Stay dirty.